Let's solve a little more difficult quadratic equation using the quadratic formula. 3x squared plus 2x plus 5 equals 0. So this is an equation that we've already solved before using the method of completing the square. It's going to be a little bit difficult, more difficult than the other examples with the quadratic formula, because we're going to have to simplify this square root of d term here. Anyway, so we already know a, b, and c, because this is written in terms of descending powers of x, as usual. So a is 3, b is 2, and c is 5. So the first equation, capital D, is b squared minus 4ac. b squared is 2 squared minus 4 times 3 times 5. So 2 squared is 4. 4 times 3 is 12. 12 times 5 is 60. So this is 4 minus 60. 4 minus 60 is negative 56, which is less than 0. So when d is less than 0, we expect two complex roots. Meaning they can involve things with I. Next up, we find these roots. So x is negative b, negative 2, plus or minus square root of d, so d was negative 56, all over 2 times a, which is 2 times 3. Okay? So you might be tempted to simplify 2 times 3 is 6, which is of course correct, but I'm not going to do that, and you'll see why. The reason is that this can be simplified. There's a perfect square that goes into 56. So if I factor 56, 4 goes into 56. So 56 is 4 times 14. And there's no perfect square that goes into 14. So negative 56 is negative 1 times 4 times 14. So when we do the square root, this is equivalent to negative 2 plus or minus, well, since negative 56 is negative 1 times 4 times 14, its square root is the square root of negative 1 times the square root of 4 times the square root of 14. And this is all over 2 times 3. Let me erase this, and I'll rewrite it at the top. Okay, so this is what we have so far. Negative 2 plus or minus root negative 1, root 4, root 14, all over 2 times 3. So to simplify, remember square root of negative 1 is just I. Square root of 4 we know is 2, because 2 squared is 4. And root 14, well, there's no perfect squares that go into 14, so we can't simplify anymore. So this becomes negative 2 plus or minus 2i root 14 all over 2 times 3. And now you can see why I didn't simplify 2 times 3 to become 6. Because this 2 can cancel a 2 upstairs. Now, a common mistake that people make is when they do this cancellation, they just cancel this 2 against one of the 2's upstairs. That's wrong. The reason is that when we cancel, what we're actually doing is factoring out a 2 upstairs and then canceling it with the 2 downstairs. So if we factor out a 2 from the expression upstairs, what we get is 2 is the quantity negative 1 plus or minus I root 14 all over 2 times 3. And now we see that this 2 cancels this 2. And so our final answer is -1 plus or minus I root 14 over 3. So effectively what we're doing is we're canceling not just this 2 upstairs, but also this one. Remember, when we do -2 divided by 2, we're left with -1, which gives us this answer here. Another way to write this is we could break it apart into 2 separate fractions, and we'll get -1 over 3 plus or minus I root 14 over 3. Now either one of these should be acceptable final answers, but I'm going to circle this one just because this is the answer we got when we solved this by the method of completing the square. Okay, I'm going to wrap up our discussion by talking about some special cases of a quadratic equation that could be solved using the quadratic formula, but probably shouldn't be solved in that way. So the first of these special cases is when b is 0, when there's no x term. So an example of this would be something like x squared minus 9 equals 0. Well, let's even make it a little harder. X squared plus 9 equals 0. We'll even make it x squared plus 5 equals 0. Okay. So the easiest way to solve an equation like this is just move this to the other side. So we get x squared is -5. And then we square root both sides. Don't forget to put a plus or minus out front on the right. So we get x is plus or minus, and the square root of -5, we should know by now, is I root 5. Now you will get the exact same thing with the quadratic formula, but it will take a little bit longer. So here, we have to write it in this form, ax squared plus bx plus c is 0. To do that, we have to write this as x squared plus 0x plus 5 equals 0. So there's a secret term, 0x, that wasn't displayed here. And that allows us to identify that a is 1. Remember, x squared is the same as 1 times x squared. B is 0, and c is 5. If we do that, we can get the discriminant. D is b squared minus 4ac, so that's 0 squared minus 4 times 1 times 5. And I'm just going to write this as, well, 0 squared is 0. -4 times 1 is -4, so we'll just leave this as -4 times 5, which is obviously -20. Okay, I'll write that too. So since this is less than 0, we expect 2 complex roots, and those roots are -b, which here is -0, plus or minus square root. And I'm going to write the factor form, -4 times 5 over 2 times a. So 2 times 1 is 2. And then, so adding -0 to something doesn't change anything. So this is plus or minus. I'm going to factor this again. So we have -1 times 4 times 5. And then the square root distributes over the product. So upstairs we have square root -1, square root 4, square root 5. And downstairs we just have 2. So square root of -1 is I. Square root of 4 is 2. Root 5 is root 5. So we write that as 2I root 5 over 2. And here the 2's cancel, so we just get the same plus or minus I root 5 that we got before. I think you'll agree, even though this can be solved using the quadratic formula, it's much easier, much simpler just to do it this way. So we just talked about the case where there's no middle term. What about the case where there's no constant term? So something like ax squared plus bx plus c equals 0, but where there's no c. So an example of this might be, x squared minus 6x equals 0. Again, this can be solved using the quadratic formula, and I'll do this shortly. The easier way to solve it is just to factor out an x from both terms. When we factor out an x from both terms, well, the first term was x squared, which is x times x. So when we factor out an x, there's only an x left. And when we factor out an x from here, there's only a negative 6 left. You can check this because if you distribute the x over these, you get what you started with. Now this times this is 0, which means either the first factor is 0, so either x is 0 or x minus 6 equals 0. So another common mistake is that people forget this first factor. So you have to set both of them equal to 0. So if x minus 6 is 0, we can move the negative 6 over, it becomes positive, x is 6. So our two solutions are 0 and positive 6. Now we can get the same thing using the quadratic formula if we remember that c is 0. So we could rewrite the original equation as 1x squared minus 6x plus 0 equals 0. And then we see that a is 1, b is negative 6, and c is 0. So when we do our discriminant, we get b squared minus 4ac, so negative 6, quantity squared. It's important to put this in parentheses. Minus 4 times 1, and don't forget c was 0. So 0 times anything is 0, so this whole term dies. And negative 6 squared, so negative 6 times negative 6 is positive 36. And then our solutions are negative b, so negative negative 6 is positive 6, plus or minus square root of d, square root of 36, all over 2 times a. So 2 times 1 is 2. Okay, so our two solutions, we take the plus sign and the minus sign. So square root of 36 is obviously 6. So we do 6 plus 6 over 2 and 6 minus 6 over 2. So 6 plus 6 over 2, that's 12 over 2. That gives us 6, and 6 minus 6 over 2 is 0 over 2, which gives us 0. So we get the same two solutions from the quadratic formula, but I think you'll agree it's much easier just to factor and solve. Okay, so I just showed you how to handle the case where there's no b and there's no c. What about the case where there's no a, where this term is gone? Well, this isn't even a quadratic equation at all, really. So this would be something like 3x plus 5 equals 0. So this is just a linear equation. We can solve this using our standard methods. So we move the 5 to the other side. 3x is negative 5. Divide both sides by 3. X is negative 5/3. So there's only one solution here because it is not really a quadratic equation in the first place. Anyway, in summary, these are three special cases of the general quadratic equation where you don't really want to use the quadratic formula, although you can if you have to. Except for this last one. You can't even use the quadratic formula at all for that one because you'd be dividing by 0. Anyway, thanks for watching. Don't forget to comment, like, share, and subscribe.